Back in the podcast with my boy Stevie. We're here today to talk about derivatives, how they work, and what you can look for in solving it.
Alright, so first we're going to talk about the secant line. The secant line is the average rate of change, or it's the rate of change over an interval. The reason we would find it is because it automatically puts us in basically rise over run. So if we were car salesmen and we had a time from 12 to 10, an interval from 12 to 10, we would take our amount of cars sold. So let's say it's 5 at 12 and 2 at 10. So we would take that, and we would take 5 minus 2 over 12 minus 10.
Basically, a derivative is just a rate overall. You can just use rise over 1, like y2 minus y1 divided by x2 minus x1 to find the slope. Overall, the slope of a secant line equals the average velocity of the position function. And then the first derivative is the graph of the position graph, of its slopes and stuff. First graph is if it's linear, then the first derivative is constant and the third derivative is 0. Talking about the first derivative, the first graph is talking about you sold 20 chickens and within 10 seconds, then the slope of the first derivative would be 2 over 1, which would just be 2, just to show that slope. Overall, it's just derivatives just complement the first or second graph depending on what you get.
Tangent lines are a bunch of secant lines together, or they could also be an interval, a really small interval. So if we wanted to find the instantaneous rate of change at 2, we would take 1.99 and 2.01 to get a really defined kind of point and get a really accurate point.
So when you're graphing, concavity of the graph can also help determine how the functions work and stuff, if it's concave up or concave down. A good point in this is an inflection point when the graph changes from concave up to down or down to up. This is a very obvious sign in the change of a graph, of the first derivative, and when it does that, it changes the first graph, which is usually your position graph. Then your first derivative, when it crosses the point of 0, usually means the slope changes from positive to negative or negative to positive on your first graph. So if the derivative crosses 0 from the negative to positive, then your graph on the first position part is.
And off of that would also go with local max and mins. So in your first graph, if you had a local minimum, so you would go from negative to positive then. Same thing, if you had a local max, you would be going from positive to negative, your slope would. But also in terms of limits, so to find our derivative, one way to find a derivative at a certain point is to take the limit of, as h goes to 0, of f of x minus h minus f of a over h. And the reason we would take the limit is because if we just took the actual function, it wouldn't exist because there'd be a 0 on the bottom. So we couldn't do that, so we would take the limit to find the derivative at that point.